generally in transistor the scaling, the effective channel length is getting reduced, and currently the Apple is currently shipping with 5 nanometer technology. So these and in the future, several in couple of years, the transistor will get reduced to 3 nanometer or 2 nanometer. Generally there is a thumb rule, like the channel length should be multiplied by 0.7, which is a scaling factor that reduces the channel size to 3 to 2 nanometers, somewhere in between. In every year, in every decade, we have been following these scaling rules, and we have got to 5 nanometer technology, and now we are going to deal about the atom and very subatomic particles and everything and all. But as the transistor size, but why are we going to deal with that? It is because, like, when the transistor size is getting reduced and reduced, the sub the channel length, short channel effects, like, as when the device becomes very small, the channel length becomes only few atoms wide. So the atoms generally transport from source to drain, and that part will get severely reduced. uh, the time and the length gets reduced, so there is a ballistic transport there happening there. Ballistic transport means nothing but the electron moves just like a gun, like, in a very short time, and it will move just straight and not in a zigzag manner. I'm just saying this video as a short note, like, but in coming lecture series, we'll just go on about each topic, and we'll just decide upon that. So the electrons move like that, and as the channel size is less, only few atoms wide, the electron moves very much simply, like with walking only few steps. uh, it's simple, but what happens is, like, the leakage current and the sub threshold voltage swing will be there. So there is a significant amount of leakage power, which increases the power consumption of the device, and which is not practical for our everyday use. This happens. So we are going to learn detail about the quantum structures and everything. Quantum wires, dots, those are also included, like, as a side note, not as a side note, but we'll go through them as well. But this is the thumb rule. We are going to go low dimensional. We are going to study about the low dimensional structures and all. And there's those short channel effects. Generally short channel effects are simple, like, not very simple. If you go deep, there are many books on single topic as well, but we'll try to not go that deep, and we'll try to resolve it in a simple manner. So we'll go come across the short channel effects, particle physics, and some electronics. We'll try to cover spintronics as well. Spintronics is nothing but spintronics is nothing but in general electronics, like, flow of electrons, the movement of electrons, the velocity of electrons determines the current. But in spintronics, the spin decides the charge, like, depending on the spin, it stores it as 1 or 0, so that it is used as a storage element. And in latest SSDs and all, everything and all, we use this spintronics very much. And in latest technology also, there are many the upcoming devices which are going to use spintronics. Yeah. And we'll deal about the spintronics as well. We'll try to learn about the nuclear physics, not like learn about the subatomic particles in the nucleus, about the electronics. Electron is also a very fascinating particle, so we'll learn deeply about the electronics and what different phenomenon it does occurs. We'll also go through some basic topics as well, like photoelectric effect and all, which are quite important. So this is an overview video of like what we are going to study, what we are going to know about. uh, yeah, that's it.